All right, so we're continuing 1.4 lines. And so the previous page was an introduction to graphing lines. The easiest way to graph a line is using the slope-intercept form of an equation. However, before we get to that, we better review what slope is. So that's what this part 2 will be about, is slope. So let's start by looking at this picture over here. So we have a zero slope if you have a flat line going across, because you're not increasing and you're not decreasing, right? And we always want to read from left to right. So you just want to go left to right whenever you're interpreting your slope. So a positive slope from left to right goes up, which makes sense. If it's going up, it's positive, right? From left to right. Negative slope would be going down. And so there you can see the zero slope, right? It's not going up and it's not going down. It's just at zero. It's not positive or negative. Now, undefined slope is a vertical line. Okay, and that will make more sense when we start to look at the algebra why a vertical line is undefined. So here's the formal definition of slope. Slope is a line that contains the points x sub 1, y sub 1, and x sub 2, y sub 2 is given by, and so they're showing you the 2 points on the line. And so probably something you're familiar with is the old term rise over run. Well, what the rise is referring to is really the change in y, the change in y. How is y changing when I go from point A to point B? Okay, how does my y change? And then the run part is going to be the effect on your x value. What's happening to your x value when you go from point A to point B? And that's called our run, or basically our change in x. And so the formula here is y2 minus y1. That's how you figure out the change, right? If you accidentally reverse it and do y1 minus y2, that's okay. The only thing is you just want to be consistent on top and bottom if you accidentally switch the order of your subtraction. So you can see the change in x, you subtract x2, or x2 minus x1. Or if you flip it, that's fine. If you reverse the order, that's okay. You just have to be consistent. Now, the difference of the y's always has to be on top, and the differences of the x always has to be on bottom. So you don't want to flip the x's to the top and the y's to the bottom. That won't work. Okay, so the first way we're going to look at this is we're going to kind of use the rise over run. That's kind of the easiest way if you're looking at a graph. And so that's what we're going to do down here. Okay, so right here on my first one, they give me these, I call them bullseye points because they're perfect points. You can see what coordinates those are. So right here, that's 0, 0, and then that point right there is, 2, 1. Let's see, 2, 1. All right, so to get from point A to point B, I have to go over 2, so I'm going to run 2 and go up 1. So if and by the way, m is short for slope. That's the variable or the symbol we use for slope right here, okay? So rise over run. So to get from point A to point B, I rose 1 and I had ran over 2. So that is my slope right there for that line. It's going to be 1/2. Looking at number 2 right here, to get from point A to point B, I'm going to drop 2. So my y value is decreasing by 2. So you want to put a -2 right there because it's dropping 2. Now my x value is increasing by 2. So that's a +2. So now my slope is the change in y. Well, the y's decreased by 2 to get from point A to point B, and the x value increased by 2. Now this is a good answer, but we want to go ahead and reduce that. So -2 divided by 2 is -1. So you always want to reduce if you can. Looking at number 5, you might recognize this from up above. It's a flat line, so you might already know what the answer is. But let's go ahead and interpret this on the graph. So going from point A to point B, I have to run 1 unit. So I'm running 1 to the right. But I'm not going up or down. So that part of it, the change in y is 0. So my slope would be the change in y, which is 0, my rise, I didn't rise, over my run, which was 1. 0 divided by 1 is just going to be 0. Okay, so 0 over any number, as long as that number is not 0, as long as n is not 0, that will always result in a 0. Okay? All right, let's look at a couple more cases here. Okay, so on number 9, they don't give me those nice points, so I got to find them myself, and sometimes it can be a little tricky. Let's see, I see this one looks pretty good right there. That looks like a bullseye point. It crosses perfectly right on a x and y value. And then you might think, oh, that looks like one, but not quite. If you look closely, it's not quite a perfect shot. So let's see, let's keep going. Same thing with that one. That one's close, but doesn't go right between the crosshairs. Looks like this one is a good one right here. So those are going to be my 2 points I'm going to use. And going from left to right, let's see, I have to rise up 1, 2, 3, 4, 5, 6, 7, 8. So I'm rising 8. It's increasing, so it's going to be a positive. And then I'm going to run 1, 2, 3 forward. So my x value will be 3, my change in x. So my slope for this, my rate of change in y, my rise over my run, which is going to be 8 over 3. And there we go. Okay, looking at number 10, I have a few that I can choose from. So let's see. Looks like there's probably one up here, right there, right there. So I've got quite a few. So pick any two. Probably want to pick two next to each other, because if not, you'll have to simplify if you pick them further away. So let's see. I'm going to use this one. So I'm going to go down 1, 2, 3. So I go down 3 and over 2, positive 2, because the x value I'm actually increasing by 2, the y value decreased by 3. So rise over run, I actually dropped, so negative 3 and then over 2. Okay, 15, once again, this will be a special one that we saw in that graph above. It's going to be undefined, but why is it undefined? So I need to pick 2 points on this line. It really doesn't matter where you pick them, as long as you just pick 2 points. They could be right next to each other, or they could be really far away. It's not going to change the result. So what's happening here is I'm rising, or you could say dropping. It really doesn't make that much of a difference. So I'm going to go ahead and put it as rising 3. And running, basically I'm going to run 0 because I'm not moving left or right, so my x value doesn't change. My x value started at negative 3 and it ends at negative 3, so that doesn't change. My y value is the one that changes by 3 units. So for my slope, I'm rising, or if you want to drop it, it won't make a difference. So 3 over 0. So whenever you divide by 0, you're going to get undefined. Okay, so a little way to remember that: under the line, undefined. So if 0 is under the line, it's undefined. So hopefully that'll help you out a little bit. Okay, so now we're going to look at more of the algebra, because you're not always going to be given a graph of your line. Sometimes you'll just be given points, and that's where this formula comes in. So as mentioned before, if you accidentally do y1 minus y2, that's okay. You just have to make sure you do the same thing with your x's. Just put the x1 minus x2. Okay, so let's go ahead and try one of these. So what you want to do is label your points. So this will be my first point. So that's x1, y1. This will be my second point, x2, y2. So you can't mix and match the numbers. They have to stay with that point. So if this is x1, this one has to be y1, and x2 has to be y2. So let's go ahead and substitute in what we know. So let's see, y2, let's see, that'll be 12 minus 4 over, let's see, 7 minus 9. So let's see, 12 take away 4 is going to be 8. 7 take away 9, that will be a negative 2. Okay? And then whenever you reduce that, that should become a -4. All right, let's look at our next one. So we'll label our point. All right, so y2 minus y1 over x2 minus x1. So 0 take away 3 would be a -3. -2 minus 0 is -2. Then the double negatives will cancel out. So we do want to write this as +3 over 2. So you want to make sure and do that. Okay. And by the way, you want to leave it as a fraction. I mean, if you put 1.5, I mean, technically that's fine, but we typically like to have it in a ratio form for whenever we use slope to help us graph. Okay, so let's see. This will be x1, y1, x2, y2. So let's see. Our slope will be 4 take away -2 over -3 minus 1. So on top, you have double negative, so we'll end up adding 2 to the 4. And then on bottom, let's see, -3, we'll put that as plus -1. If you know it's -4, that's fine. You don't have to show this extra step. So let's see, 4 plus 2 is 6. -3 plus 1 is -4. And then we do want to reduce that. So that'll reduce down to 3 over -2. Or if you want to, you could just put the negative right out in front. Or if you want to, you can put it with the 3. So any one of those is going to be correct. So put it on bottom, out front, up top, doesn't really make a difference. All right, so our next one, let's see, x1, y1. So once you do a couple of these, you get the pattern down. It's really not too difficult. So let's see. -8 minus 1 over -3 minus 9. So you're already down 8. We're going to take away another one, so that'll be -9. This one you're down 3, plus we'll take down another 9, so that will become -12. Okay, so I didn't show quite as much work here. So let's see, you do have double negatives, so those cancel out. So now you have 9 over 12, +9 over +12. Now those both are reducible by a factor of 3. So we'll go ahead and do that. So we end up getting 3 over 4. Okay, got a couple left. I'll leave that up there for a minute if you're still looking at it. Let's see. So x1, y1, x2, y2. So let's see. 3 minus 3 for my differences of my y's. And then -6 minus 4 for differences of the x's. So we're going to end up getting 0 over -10. And so we talked about this earlier. 0 divided by any number, as long as that number isn't also 0, will be 0. 0 right there. Okay. So looking at our last one here, we'll go ahead and label the points. All right, so let's see. M equals -1 minus 6 over -8 minus -8. So let's see what's going on here. So on top, we're going to get a -7. On bottom, this becomes -8 plus 8 because we have the double negative right there. So we're going to end up with -7 over 0. If 0 is under the line, it's undefined. All right. Okay, so that's slope. And so in the next video, part 3 of this section, we'll start to actually graph the lines using our slope-intercept form.